I wanted to briefly mention in the film that I did about how to create the pulsar, I didn't really show how these inputs were using it. So the signal to send a signal goes just directly through the pulsar and up to one of the power lines, one of the telephone lines. Um, the actual signal, which is sending the ones and zeros, is ANDed. This is an AND gate with the pulsar. So the way an AND gate works is you can see right here. You just have 3 blocks, the 2 sides with redstone torches on them, a piece of redstone in the middle, and on the side another redstone torch, and this will be the AND of these 2 signals going up through this telephone wire. So that's what I wanted to explain about that. The next thing I want to show you is my 5-bit shift register. When I showed you how the overall thing works, at the beginning I showed how the signal gets sent to this shift register, which is basically the way this works is, okay, I've already got these here. So this side is the reset or the clock signal. So if I flick this, you'll see that these bits get shifted to the right. So there's 2 bits there now. I'm going to flick this. They get shifted to the right. Now the 2 bits are at the far end. And if I keep shifting to the right, eventually all the bits will clear out. And just show that again. If I send 1 bit here, it's initially right here. I'm just going to shift it all the way down. Click once, it's shifted. Now it's over there. Now it's over there. And that's the last one. And basically the reason for this is because we're sending the signals as a serial signal, which means we're sending them one at a time. So there's no way to transmit 5 bits without putting them in some kind of register that remembers what was sent. So when I send 5 of them, they'll all show up here. So I'm going to show you how to create the shift register. Basically, what's needed for this is a bunch of wood, or I guess I already have it, or any other block. Really doesn't matter. You need redstone lamp or something that's going to light up, tell you what the output is. You need repeaters. You don't need the piston. That's pretty much it. Just the wood, the redstone torches, repeaters, a couple of levers, and some lamps for the output. I need something else I'll probably remember later, but whatever. So the basic unit in our shift register is this. It's a memory cell. So the way it works is you put 2 NOT gates. That's a NOT gate, and this is a NOT gate, and you want to feed their inputs to each other like this. And what this does is, since this is a 1, this is not 1, and this is not 1. So it's like a memory cell. It just remembers what you had there before. So I'll show you kind of how that works. Here's our set, and here's our reset. Okay. So the bit is set high. This is our output. Okay. Just put a lamp here. This is our output. So it's set high right now. Nothing I can do with this will change that. But if I come over here and hit reset, now it's low again. And nothing I can do over here will change that. So that's kind of how it works. You have to set it, nothing changes, and then reset it, and nothing can change. So that's the basic unit in our 5-bit shift register. So here's 1. memory cell, we need 5 of these. So let me just set up the other, well, I probably won't do 5. Well, maybe I will. Hang on 1 second. What is it? Times A. Okay. So here's the second cell here, second memory cell. Same thing as the first one. Feed their outputs to each other. And we want to give them the same reset signal. Do we? Wait, let me just make sure we do want to do that. Yeah, we want to feed them the same reset signal. So, what I'm going to do is I'm going to move this over a little bit. I'm going to move it to maybe right, just to be safe, right? Well, probably right there. Okay, so this is our new reset signal. So we need to feed this signal over here. Okay, so that's for that one. But what I'm going to do is I'm going to put a repeater in there. It kind of acts as a diode to make sure this signal doesn't come back this way. Okay. Now I'm going to keep feeding that signal all the way over here. Put another diode and feed it to this one. Okay, so now they both have resets. Now this is a shift register, so what that means is whenever our reset, or our clock, you can call it a clock, happens, this bit over here is going to be shifted to this bit. So what we want to do is we want to make an AND gate of this reset over here and this input, or this bit over here. So the way we do that, get rid of this, is to make an AND gate, like I said. So that requires 3 blocks, like this, and a torch on either side, like this, and a torch right here. I don't know if I'm doing this right. I think I'm doing it right. And then finally, redstone in between the two, like this. Right. So we want to take this reset right here and feed it into this side of the AND gate. Then we want to take this and feed it into this side of the AND gate. But for timing purposes, it turns out we need another delay right here. Actually, I think in the other one I have 2 of these things to make sure the delay is good. So we'll put 2 of those just for delay, and we'll feed it into this AND gate over here. So now this becomes the AND of this and the clock or reset. So let's just see what happens here. Let me put a couple lamps back here to show the output. There's one, and the other, and let me go ahead and reset everything. Okay, so now I'm going to feed this one a 1 as the first input, and then flick the clock on, and now you see this bit has transferred over to there. So yeah, it's working so far. I think I'm going to do one more just so you get the hang of it. When you do 5 of them, you do encounter some delay issues, but it's the same general principle, and you can just mess with the different diodes where you place them, or different repeaters where you place them to lessen the delay in some instances. Okay, so I'm going to do a third one here. So 1, 2, 3, and put it here. Okay, so this is our third memory cell, same as the other ones. Okay, feed the inputs to each other. Alright, that's working. Now we want to keep the same signal here. This is the reset being fed into it again. And we want to do our AND gate again. Right, so 1, 2, 3. Put one on each side over here. Put a redstone in the center. And a torch on the edge. And then we want to again feed this into this side with 2 repeater delays. 1, 2, set all the way to maximum delay. Oops. Feed that into there. We also want to feed our reset into this guy. And I think that's it. Oh, and let's show the output again. Right here for the lamp. Okay. So I'm going to reset the circuit again. Yep, that's fine. See, the delays I was talking about before is you need to put repeaters on this line because the signal will fade away. I think you can only send up to 16 blocks per input. So let's see, 1, 2, 3, 4, 5, 6, 7, 12, 13, 14, 15, 16. It's barely, it's right there. It's barely enough to get out here. So yeah, let's see how this works out. Send a 1, send it over again, and we're done. Now I'm going to send, just for the hell of it, let's send a 1, 0, 1. So there's our 1, shift it, 0, shift it, and 1. That's how you would send a 1, 0, 1. Yeah. So basically that's how the 5-bit shift register works. And you'll see this is the pulse that was sent from the other side, and that's going to be our reset. And this is the signal. So whenever the signal comes in, well, let's see. Yeah, so both the pulse and the signal are sent at the same time. So like if I send a 1, this will be 1. The next bit I send will trigger the pulse and also accept the next bit that I put in. So that's kind of how that works. I don't need these. So again, as you can see here, I needed to put diodes here, or redstone repeaters here, to keep this signal alive. And you'll have to mess with that on your own to make sure it works fine. And yeah, that's basically how this works. Let me just go and give another demonstration of the whole setup. And yeah. So I think they were all clear on the other side, but let me just make sure. I'm going to clear everything by sending 5 0 bits. Okay, there's 5 0 bits. Now I'm going to send 1 0 1 0 1. So there's 1 0 1 0 1. Alright, let's see if that worked. Oh shit, what did I do? Of course that didn't work. What the hell happened? Let me just try clearing it again just to be sure I cleared it to begin with.